All right, very good. So, first of all, I hope you had a great weekend. Um, Everyone probably is at their own homes and everyone is safe. So, let's get started on today's session. And this particular session, it's basically the onset of us doing an API integration to our project. All right. And in order to do that, we have to use Redux-Saga. And also, there is a library called Axios that we'll be using. It's a promise-based library. So all those things would happen, and for implementing those kind of functionalities for the API integration and for the Redux-Saga implementation, we have to learn a few JavaScript syntaxes which are related to ES6 features. All right. So this session, it would not be Redux-Saga essentially, but in this session, we'd be preparing ourselves to get an understanding of what Redux-Saga would look like. And then in the next session, that is the day after tomorrow, we'd be actually implementing Redux-Saga based on whatever we have learned today. All right. So this time around, we are not going for Redux-Saga. Redux-Saga would help you to integrate API with a Redux and React setup. But this time around, we are going to clarify some syntaxes from ES6 where it would help us understanding Redux-Saga better. All right. So let's create a day 6 folder. We are halfway through, by the way. So let's just copy. Yeah, I think I'd be using this project, and then I'll actually clone it from GitHub. But I'll be using our project as well for adding a service layer to our project. So I'm just copying a couple of things in here. We'll copy this, and I think, yeah, I don't need the topics.txt because today's topic is completely different. It is not Redux that we are talking about. So I'll copy this. I will clone my project from GitHub. Let me just open up GitHub real quick. And this is the project that we're talking about. Let me clone this one. And I would go into the project and I would just go for a yarn setup so that it downloads all the node modules and paste this in the node modules directory itself. So that can be there. And at the end of the day, of course, I'll be committing the current day's changes inside this repository. So let's minimize this and let's see what we are going to do today. So in today's session, we are going to learn two ES6 features. One is promises and one is generator functions. Promises would help us to understand the asynchronous nature of JavaScript, and also it will help us to call APIs from an API server. So we will also be setting up a dummy API server in today's session as well. I'll put it in the task manager folder itself, that particular dummy JSON file. So there is a library which is called JSON server that we'll be going for. It's a dummy API server creation library, and it's a REST API server, by the way. So I believe everyone knows that REST API has certain rules where certain HTTP verbs are used for certain specific purposes, like get, post, put, delete, patch. These are the majorly used HTTP verbs. We'll be using get for getting data from the server. Anyone, what is post used for? Any suggestions or any ideas? If we talk about REST API, submitting data, you may say creating or maybe adding data to the server. All right. What about put as per the REST API? Yeah, creating new data would be a better word. New data or new entity to the server. Okay. Put is used to update the data on the server. What about delete? Of course, like it is for delete. And patch. What about patch? Anyone, any ideas? Patch is used for what? Partial update. Very good. So if you're not updating the whole object, you're maybe updating a couple of fields only. It'll be patch that you'd be using, and most of the time it'll be patch that you'd be using. Put might be very rarely used. That's what I've seen. So these are the REST API rules, and all of them would be followed by JSON server on every resource that JSON server provides us. However, this is a dummy API server. It's a file-based one. Should be creating a JSON file and then going for a certain certain resources in there, like tasks, for example. So this is something that we'll be going for, but then what I would expect you to do is you should replace this JSON server with whatever the backend programming language that you know of, like PHP or Node.js or ASP or Java, JSP, Spring or Hibernate or whatever framework that you know of. That would be an ideal thing to do. However, the current sessions that we are going forward with are purely React.js sessions. So I'm not focusing too much on the server side at this point. We're just going for a dummy REST API server. All right. So this is what we'd be setting up in our computers. And we'd also like to go for ES6 features, which are promises and generator functions. And if you recall, on the first session, I mentioned that promises and generator promises and generator functions would be some things that would be covered when the right time comes. So this is the right time. And we'd also be covering another library, which is called Axios. And Axios is a promise-based REST API client library. All right, promise-based REST API client. And it is used, like if you check out the definition of Axios, like the description of Axios that is given in the official website, actually it's a GitHub repository. Okay, so what it says is that it is a promise-based HTTP client for the browser and for Node.js. All right, so it is not necessary that you should be using Axios only on browser-based applications. But if you want to use Axios on server-based applications like a curl request handler or something like that, that also can be done. So I'll just copy this definition. All right. So Axios is a promise-based client. Now Axios has several methods like Axios.get, Axios.post. It's an HTTP client, so get, post, put, patch, delete, everything would be available with Axios. .put, Axios.patch, Axios.delete. These are the major methods that we'd be using as far as Axios is concerned. But then there are other methods as well. There is a very good reference of Axios provided here. And there are so many things that Axios can do for you, right? It can prepare your request. And there are so many features that are available that way. So I'll just copy the official GitHub repository of Axios in here for your reference. And also I'll copy the JSON server repository. That'll also be better. Okay, I'll just copy the official JSON server npm page. That's also one and the same, and it has the GitHub repository as well. Anyways, I'll copy this and let me paste it here. All right, so basically if you're creating a server which is a REST API server, you can use Axios to send in requests like get, put, post, delete, patch, delete, get, put, post, delete, patch, and so on and so forth. And Rita asks, like, is it an alternative for Ajax? It's not an alternative, Rita. Axios implements Ajax in the background. Like Axios implements fetch, and fetch implements Ajax. So it is using Ajax in the background essentially. So it's no replacement, but it is a better way of managing Ajax calls. All right. I believe that answers your question. Very good. So Axios, and these methods that we have, it would return us promises, and that's why it is very important for us to learn what promises are. All right, so we will, these get put post delete patch all would return us promises. So we'll see what promises are, and we'll also see what a generator function is. And as far as our task manager project is concerned, let me just set up the agenda for today. So we'll definitely learn, first we'll learn what are promises. All right, for that we'd also like to see async programming demo. So promises are async, all right? So rather than going for promises, an async demo, we'll see how JavaScript is asynchronous and what is basically asynchronous. That is also something that we would check out. And then we would go for promise creation. And the thing is, like, majoritarily you would not be creating promises in your projects, but you would be using promises that other libraries create for you. For example, Axios.get creates a promise for you, so we'd be using that promise. Right, you'd not be creating any promise, but it's always a good idea to know what is basically happening in the background, what is the code going behind this whole promise creation, so that we understand promises better. All right, so we'll just go for a promise creation demo as well, and then we would add in the task manager project a service layer. Now, a service layer is not necessary for our task manager project to function, but it is always a good idea to add a service layer in any project. So we would add services that would allow you to, go for API calls and go for these kind of Axios.get, post, put, patch, and delete type of functions. All right, so a service layer has to be added in the task manager. We may try to, call a couple of services at some places, but then we would take them off because we don't want that services to be called at this point. We would like to have Redux-Saga call the services, but that's a different story. All right, so task manager, service layer, and then we'd like to also check out the syntax for generator function. So with all these in place, we would be all set to use Redux-Saga. So as I say, today's session is more or less a preparation for us to get Redux-Saga setup done, but not the exact Redux-Saga setup for today. All right, so we are just preparing our project and preparing ourselves for the Redux-Saga setup. So I believe the agenda for today is clear to all. Yes? Very good. Very good. And let's start with async demo first, and then we'll go with the promise creation. So yeah, so this project is also created. Let me just minimize this and let me close this up. I'll create a folder ES6. And in here, I'd like to open it up actually in the separate terminal, so that it stays side by side, or maybe I'll use the built-in terminal. I'll just close this one. All right, so I'll create a first file. I'll call it timeout.js, and in here I'll be demonstrating a couple of functions to you, which are ES5 functions actually. Nothing related to ES6. It was all from ES5 that was there. The two functions, let me just write them down in here. One is set interval and one is set timeout. Now, we would have been using this set interval and set timeout in our day-to-day JavaScript programming. We'll try to find out what they exactly mean. All right. So if we talk about set interval, let me just maximize this out, or maybe, yeah, set interval to start with. And set interval would have a handler function, and the second argument would be the interval. Let's say I go for 1000. So 1000 milliseconds. So 1000 milliseconds is basically basically 1 second. All right, so we want to execute this function every 1 second. So let's see if I do a console.log hello. All right, and if I open up my terminal and if I run this one, you'd see that in every 1 second this would print hello to us. And And also one thing is that it doesn't stop the program. Like the program keeps on running and running and running, like something like it's listening to a server or something like that, right? So it's listening to something. The event loop in JavaScript is keeping on running. So this is basically set interval. But if we talk about set timeout, all right, and say for example, if I just go with like 4000, that is 4 seconds of timeout, and if I run this, all right, see what happens is it waits for 4 seconds, it displays the output, and it stops the program. So that is the difference between set interval and set timeout. Set timeout just executes the interval once and it then stops the program altogether, while set interval keeps on executing the handler on every interval that we have specified, and it doesn't stop the program as well. All right, so it keeps on running the program one after the other. So that is the first difference that we have to take care of. So I believe everyone understands the difference between set interval and set timeout, right? Okay, now I would like you to tell me one more thing. If I go for something like console log inside and I go for a console.log outside, if this is the case, and if I try and execute this program, what do you think would be the output? What console log would be executed first and what would be the next? All right, outside first, inside next. Absolutely. Outside first, waiting for 4 seconds, and then inside next. All right, pretty simple, like pretty straightforward. Now, if I, for example, is there any other way to create an event scheduler? Set interval or set timeout. These are like set timeout is the best way in JavaScript for a scheduler to be created. But then you can also go for, like, if you are talking about server side, then there are a lot of things like cron job and all those things. But on the client side, it is still set timeout. That is the best way to do it. Or set interval if you want to have a recurring event. All right. So if I take off the timeout itself, which means 0 milliseconds, I'm not setting any timeout. So it has to be instantaneously executed, kind of a thing. So if that is the case, now what do you think, which would be the sequence that will be following? Anyone? Now, when I ask this kind of a statement or this kind of a question, it is never a straightforward answer. However, Palak mentioned that it would be first inside and then outside. What about other participants? Shweta also mentions the same. All right, Rita also mentions the same. Let's see. If I run this, it still gives me the same output. However, it doesn't wait for the set timeout to happen, but it instantaneously displays the set timeout. But then again, same output, outside first and inside next. Now, that is a weird behavior. It should not happen. So we were thinking that, okay, inside should be the one that should be executed first. But why is it happening so that this set timeout is executing last? The reason is that the set timeout is an asynchronous function. And what is asynchronous? When we talk about synchronous and asynchronous, synchronous means everything is happening one after the other, all right? And asynchronous things are not necessarily happening in sequence. They happen as per the convenience or as per the conditions that are there. So because JavaScript, it's running on the browser, and JavaScript, because it runs on the browser, it is a single threaded mechanism. The browser could not afford multiple threads because then it will be really heavy for the browser to execute. So from the day it started, JavaScript was a single threaded mechanism. But you already know that when you program in JavaScript, when you program the UI, it is always virtually showing us that everything is executing in parallel. Like, for example, first the UI is loaded, then the data is parallelly loading in the background and all. So that is all happening. A virtual environment of a parallel processing is created. But because JavaScript is single threaded, parallel processing is not at all possible. So how is that happening? The answer is that most of the time, anything that is not predictable, like an API call, which may take some time to come in, or which may not even come in, the response may not even be shown. That kind of things are always asynchronous. Similarly, set timeout are also asynchronous. Like the program here, it doesn't wait for set timeout to happen, but it executes whatever synchronous code is available. All right. So set timeout being asynchronous, it would not execute the set timeout right away, but first JavaScript would execute everything that is synchronous. That is, for example, the line number 5. And everything that is asynchronous always is appended to the end of the execution queue, like the set timeout or like any API call. Anything that is asynchronous always gets appended to the end of the execution queue. So that is the reason why set timeout, though there is no timeout specified at all, it is the default nature of JavaScript that anything that is asynchronous goes to the end of the execution queue. Hence, set timeout goes to the end, and outside, prints first. All right. Similarly, if I go for something like this inside 1 and inside 2, I think now you know what the answer would be. Now, can anyone tell me what would be the order of execution in here? Okay. Outside, inside 1 and inside 2. All right. So if I run this, that will be the case. Outside, inside 1 and inside 2. What happened was this got executed first, but because this is asynchronous, it got appended after the console log outside. Similarly, then this gets executed, but then again this is asynchronous, so it gets appended towards the end. So outside gets called first, or executed first, and then this console log happens, then this console log happens. So again, if I go for something like this, all right, so if this is the case, what could be the output? First outside, then inside 2, then inside 1. All right, and inside 1 would come after 1 second. So that is also one thing, like outside, inside 2, inside 1, and so on. So I believe everyone gets this whole idea of asynchronous programming. The response totally depends on how much time it spends to get us the response. And as soon as the response comes, it gets appended to the end of the execution queue. All right. So I believe this whole concept of asynchronous programming in JavaScript, it's clear to all. Yes. And here we have used set timeout as an example for asynchronous processing, but normally it'll be an API call or something like that. That would be asynchronous, and that is also meaningful. Having an API call to be asynchronous, because when you exactly at the moment when you call an API, you don't know what the result would be. So it's better that we execute it at the end and execute everything that is predictable first, and then the rest of unpredictable things can be executed at the end. That's pretty meaningful that way. All right. How to bind with output of other function to execute the next function. Yeah, so basically you want to execute, for example, set timeout after this happens. Is that correct? After, let's say we want to wait for 1000 milliseconds and then you want to execute something, that kind of thing. It's what you're asking, right, Palak? Yeah, I would come to that. Promises actually would help you in a better fashion if you want to make things sequential. All right, so we'll come to that in a while, and we'll see how those things can be done. All right. Okay. So this being clear, we would now like to check out the promise-based mechanism. Just a second. Was drinking some water. All right. So a promise-based mechanism is what we want to now check out. So if I go for promises are mechanisms that help you to basically manage asynchronous programming better. All right. Promises themselves are asynchronous, but they would help you to manage the asynchronous programming better. And one of the requirements that Palak mentioned of binding the output of one function to the other, basically waiting for one function to happen and then going for the other, is something that promises can do for you. That kind of organizational capacity is what promise has. All right. So first of all, if we talk about a promise by the name itself, it's clear like what it is. All right. And if I for example, take an example of an asynchronous process, which is an API call to a server. So whenever you call an API call, whenever you call an API on a server, and if you're using a promise, then the server would not return you the data right away. We all know that servers can be busy handling other requests. So whenever you call an API, the server would not right away return you the data, but it will return you a promise. And the promise is something which means that, okay, I'm not giving you the data, but I'm giving you a promise that I'll give you the data when the data comes. All right. So that kind of a definition is what promises follow. Like, not necessarily all the time servers return promises. Like, servers return us the data eventually, but then there are certain libraries like Axios that give us promises. All right. Most of the time the promises are fulfilled. Some of the time the promises are not fulfilled. So say, for example, if a promise is fulfilled, then it is called resolving a promise. All right. And if a promise is not fulfilled, it is called rejecting a promise. All right. So say, for example, if we call an API through Axios, Axios would not give you the data right away. Axios would give you a promise. And later on, when something comes from the server, the promise might either resolve or reject. All right. So if a server returns data successfully, the promise would resolve. If the server returns some error, like a 404 or 401 or 500, then it'll be rejected. All right. So resolve is handled often by a method called then, and reject is often handled by a method called catch. All right. So catch, it's also like an exception handling catch. So if there is an exception in your code as well, this catch method would automatically be invoked. So we'll see how things work as far as then and catch are concerned. But we'll try to go for a promise creation in this particular case. And as I said, normally you'd not be creating promises, but you would be using promises, which Axios like libraries would create for you. All right. But they would make managing data, asynchronous data, a very convenient thing to do. All right. So let's create a promise here. And I do it like this, new promise. All right. Promise itself is available in ES6. So you don't have to import anything or anything like that. It's already there. All right. So we can store this into const promise is equal to new promise, something like this. And if I do a console.log promise, just wondering what promises are, just to log everything in the console. This, first of all, this will give me an error. Like if I go for promise, what it says is promise resolver is undefined and it's not a function. So which means that like there is one argument that the promise constructor expects, and that is a function. Has to be a function. All right. Should not be undefined. So this is how you create a promise. All right. And if I now run this, it'll give me promise pending. All right. So why is it giving me promise pending? Because this promise that we have created, we have neither resolved it nor rejected it. So it's in a pending status. All right. If I resolve or reject it, you would see what the promise would be going for. So if I, for example, want to resolve the promise, I have to pass in a function inside this function, which is called resolve. Resolve is a function, by the way, and you can call it, for example, resolve. All right, I call it as a function. And this means that the promise would be resolved, which means it's a success. So if I run this, you can see that the promise is no more pending. It gives you undefined, but undefined is basically whatever you specify inside the resolve. So whenever, for example, you resolve a promise, you might need to send some data out. So that data can be here. So like if I go for something like test, all right, so that will be promise, and test would be the data that it returns. So we can resolve a promise like this. And now you can imagine that, okay, if an API call has to happen, an AJAX call can happen inside the promise. And whenever the server returns us some data, we'll just resolve the promise. If a server, for example, doesn't return us data and returns us an error, then we'd be rejecting a promise, which would be something like this. Reject would be the second argument. And if I reject, all right, it would right away give me a very long error. First of all, promise rejected, and undefined, which means there's like nothing that has been passed. Now I'm passing an error. So let me just run it again. Now you can see that promise rejected, and this string is also shown. But then there is a unhandled promise rejection warning, because whenever a promise is rejected, there has to be a catch block to handle that rejection. which is somewhat compulsory. Otherwise, it will give us a warning and maybe the whole thing would fail. It tells us like a promise which was not handled with a catch. All right. So usually when you go for a promise, you do something like this. Like let me just get rid of this for a while. You do something like promise dot then dot catch. So we are chaining then and catch together. You can also chain multiple then methods, and that's where Palak's question would be answered. But a chain of then and catch can be created, and then and catch both have their own callback functions defined internally, like this. All right, and then let's say, let me just take them into different lines so that they're more readable. And catch would be here. So let's say if I have a console.log inside then and console.log inside catch. All right. And in my promise, I just do this resolve. So what am I doing is I'm making it a success, not a failure. So if I run this, what do you think the output now should be? All right. Okay. All right. Inside then, very good. Very good, everyone. So if I run this, you can see it gives inside then. If I reject the promise, you can see that it will give you inside catch. Now it doesn't give you that weird error or a warning because now we have defined a catch block. And let's say, for example, if you resolve this, for example, resolve message, let's say test. So at this point, I'm passing an object. We can pass anything inside the resolve function. So whatever I'm passing inside as an argument, the then method would get it over here as data. All right. And I can display the data if I want to. So if I run this, you can see inside then, and then the data is there. So this is also a way where you can go for passing data from the resolve function to the promise. So you can also imagine that if an API call happens and if the API returns as a JSON object or an array or anything like that, then the resolve would happen with that particular data, and that data would be taken and then processed while the promise is handled. All right. So this whole thing is something that promises provide as a facility. So now let's see this. Like if I go for something like console.log outside promise. All right. Inside then, inside catch, outside promise. So now if we think about this whole execution, what do you think would be the sequence of, or what would be the display as far as the output is concerned? Remember, I'm resolving a promise and not rejecting this. Outside promise, inside then is what Shubham says. Anyone else? Any other options? Outside promise, inside promise. Okay. Okay. If I execute it, outside promise, inside then. That's absolutely correct. So what it means is whether this block of code, line number 5 to line number 11, is this block, is it synchronous or is it asynchronous? Ajay says it is synchronous. Shubham says asynchronous. Ankit, asynchronous. All right. All right. Majority say async, and that's correct because that is the behavior that we saw. Like outside promise, this one line is synchronous, so this is executed first and then this is executed next, and that's why this inside then comes in. Like this line itself is executed first, but because of the nature of the asynchronous programming, the callback gets executed at the end. All right, so I believe, Ajay, that is clear. Very good. And then of course, like as I said, promises itself, they are asynchronous, but then they can also handle asynchronous things better. So say set timeout, if we go for, and inside the set timeout, I do a resolve. maybe after 3 seconds. All right. So what am I doing is like I'm waiting for 3 seconds inside the promise itself, and after 3 seconds I'm doing a resolve. All right. So this is expected after 3 seconds to be executed. Outside promise would still, oh, there's a catch block that has happened. So let's see what is the problem here. Oh, I you see that I misspelled timeout. No, I did not misspell actually. Yeah. So it is set timeout, and that's why this catch was happening. See what happened here? This is a legit exception inside a program that I didn't actually type things correctly, and that's why this inside catch happened. It also acts as an exception handling catch. That's a good thing to go for. So let me just execute it now. Outside promise, and then after a few seconds, inside then would be executed. So that is pretty appropriate. Now we can also chain the thens, as I said, like for example .then can be done, and this would mean that after this then this one would be executed. So one execution of the function would be bound to the other one. So that is also something I believe Rita asked the question, or yeah, Rita probably asked the question, or Palak asked the question, I don't know. So if I go for a console.log, let's say inside then 2, all right, something like then 1. So what would happen here is that I go for outside promise, then will be inside then 1, and then inside then 2. So see that this kind of a sequence is still maintainable. All right. And if you want, you can also pass some data from the first then to the second then. This kind of a chaining is possible. So if I, for example, want to pass the data, I'll just return something like return, let's say data.message I return, because this is an object that I'm passing. All right. So data.message, and that message would be passed in here. All right. And this would be displayed like this. All right. So if I rerun this, you can see outside promise, inside then the whole data is displayed, but then I'm returning just the data.message. That simple one variable is taken in here, and that string is displayed in the second then. So you can pass anything from the first then to the second then. That is always possible. All right. So that type of a chaining would be really helpful for us. And Shubham asks how we do same thing with loop. I don't think you can do the same thing with loop, Shubham, because this is a very different scenario. Like for example, think about it, like this portion would be in one file, all right, and this other portion, let's say for example this second then would be in another file. So that kind of modularized system is what we are talking about. And one module like promise.then in one file, and then that file returns as something, the other file gets the then gets the second then to call. So that kind of a system cannot be done by loops essentially. All right. So this is a different thing, it cannot be compared with loops though. All right, Shubham. All right. So just keep in mind that the chaining of thens is possible, and eventually what we are targeting is this kind of a thing would be in one file and this would be in another file, and so on and so forth. So that is something that we are targeting eventually. But I believe the whole way a promise can be created, or and more importantly a promise can be executed, is clear to all, right? All right. Okay. And then there is also a question that, okay, if we want to wait for a promise to happen and then and only then do this console log, how is that possible? All right. So that is also possible. Like JavaScript has a set of syntaxes that would help us do that. So let me just comment this out. Let me just take this promise separately. All right, I'll just bifurcate these things. So I take this promise again, and what I want is basically I want to do a console log, outside promise, but I would like to wait for the promise to happen, and then I would like to execute the console log outside the promise. That is my next problem statement. And Jinesh asks, is it ES6 syntax? This promise itself is Jinesh asks that is it ES5 syntax. All right, so the promise syntax, Jinesh, the new promise and all, this is ES6. All right, it's only the set timeout is ES5 that we used. All right, Jinesh. And based on a condition, can we resolve and reject? Yes, of course. That is the whole point of having a resolve and reject. Like based on any condition, like for example, if, for example, let's say math dot random, and it generates a random number. I think math dot random multiplied by 100 would give us a number between 1 and 99, or multiplied by 10 would be better. So if math dot random multiplied by 10, right, and then I'll also round it up. So basically I'm generating a random number from 1 to 10. Let me just check whether this works. And based on that condition, I'll just oh, actually I didn't have to open a browser. Just run the node REPL and I'll do this, right? So this generates some random numbers. So basically I'll create a condition where if the number is greater than 5, then resolve. If it is less than 5, then reject. So if that is the case, I can do something like this: greater than 5, then resolve, right? Else reject. All right. So generating a random number from 1 to 10, between 1 to 10, and then testing this. So I can then go for like promise dot then or dot catch, and let's say data and error, console dot log data and console log error. All right. So if this happens, then based on any condition, let me just exit out of it. You can see that it may either give me greater than 5, all right, or sometimes it may give me less than 5. Yep, you can see that it gives you an error that is less than 5. So it can be done, like it is to be done based on a condition every time. So a resolve and reject would be there inside a promise when the promise is created, and it would always be some condition or the other based on which it is resolving or rejecting. All right, I believe that answers your question, Shweta. And I believe everyone is clear with this this one thing that I did over here, right? Please confirm. Very good. So let's also comment this out, because what I want to demonstrate actually, it is basically waiting for the promise and then letting the other programs execute, or other lines of program execute. So this is my promise. All right. And I want to wait for the promise to happen and then execute something. So console.log outside promise only has to execute if once we wait for the promise to happen. So if you want to wait for a promise, you do this: await promise. All right, await the variable that we created, that is promise. And if the resolve returns some data, you can actually store it in a variable like this: const data is equal to await promise, something like this. So this would guarantee that first, this line number 5, it would wait for the promise to get executed for 3 seconds. Once the promise executes, then it would execute the rest of the lines altogether. So I can log the data in the console and then execute outside the promise. So that is something that is possible. But if I execute the code right away, there'll be one small error that it'll be giving us. And that would be, let me just run this. You see that await is only valid in an async function. And this error is also pretty meaningful. We already have established the fact that JavaScript is a single-threaded mechanism. All right. And if, for example, we're waiting for something to happen, it means that we are actually stopping the whole thread. It is the only process, it's only the processing capability that JavaScript has, and we are stopping it for something to happen, which should not be the case. So if you want to use await, you have to mark the entire block as async, so that the asynchronous block is a separate execution, like const main, or maybe I can just go with like a function, which is an async function main can be done. And this whole thing can be displayed in here. So this marks the whole main function as asynchronous function. And this means that now we can wait for anything inside this function, whatever it is. So if I go for like main and then save it, this is a function call that I'm going for. All right. And if I run this again, now you see that this is waiting. And after 3 seconds, first it displays the data, and then it displays the outside promise message. While this main itself is an async function, which has to be there. So say, for example, if I go for something like console.log, after the main, I type in outside main. All right. So if this is the case, and also let me just do another console login here, console.log inside main. All right. And instead of outside promise, there's no outside promise kind of a thing. I'll just say after promise. All right. So and here is that promise data, right? So we have a like a four console logs now: inside main, promise data, after promise, outside main. So if this is the case, provided the whole discussion that we had, what do you think would be the sequence of these 4 console logs? Anyone? We can change the name, Shweta. Main is not any keyword. It is just that because this is the main function, I just named it main, but not necessarily that. So can anyone tell me the sequence? Very good, Jinesh. Outside main, inside main, the data, and then outside promise, after promise. Very good. Jinesh and Palak both have replied with the same thing. So inside main gives me inside main first. Strange, right? And I think if I do this, when I wait for the promise, that would happen actually, right? Outside main, and then we are waiting for the promise inside main and promise data. So basically this function is asynchronous. As soon as it goes into the waiting period, you can see that the output is what we are expecting. Otherwise, it was inside main first, all right, because it was not waiting for anything to happen. All right. So this kind of an asynchronous behavior can be invoked by marking a specific block of code to async, like this function async. The more important thing is, if you want to wait for a promise to happen, your function should be async. Otherwise, it would stop the thread. So JavaScript has a rule that way, that if you're using await, use async all the way. All right. So I believe this async await scenario, it's also clear to all. Like to have a confirmation from everyone. Very good. What about other participants? Please confirm. Just like to make sure that everyone is on the same page before moving forward. Okay. Okay, very good. So, so this happens, and these are certain things that you should keep in mind while going for JavaScript programming. If not in React, they would definitely help you when you go for some Node.js programming as well. So these kind of things would be there. And as I said, we'd not be using promises, but we'd be using libraries that would give you promises so that we can go for a resolve or reject, like then and catch kind of a thing. All right. So now coming back to our project, let's try and use the task manager and try and create the service layer inside the task manager altogether. And remember, service layers are not necessary for us to get going, but what I found by programming with Angular or Vue.js, that a service layer creation would not be a problem. It will actually be a helpful thing for any project that we go for, and we are cultivating that habit of going for a service layer all the time. All right, so I would like to go into the task manager project that we have. We have cloned it from our GitHub repository, and I would go for creating a service layer, and that service layer would contain the API calls, and I would choose one of the components to call an API, but that would not be the eventual the eventual manner that we'll be calling an API. We're just testing this particular API creation. So first of all, I would like to create a service layer, and for that I'll create a services folder, and there will be a task service that we'll be having. All right, and inside this task service, as per our UI, I need three functions, three methods for the service. And let me also start my project. So now, can anyone tell me, if we are talking about a task service all the way, what are the three services, or what are the three methods of a service that we are willing to create? Anyone? Just base it on the functionality that we are having. List, add, and delete. Very good. List tasks, add task, delete task. All right, or get task would be a better name. So I'll go for export const get tasks will be a function. Add task will be another function. This add task would take in some data. Data, what I'm willing to have is something with a property title and description. All right, and delete task, what I'm thinking of is having an argument as ID. All right, so these are the three functions. That is totally based on the UI that we are having. These are the three functionalities that we need as far as the UI is concerned. All right, and then there will be also a task detail page that we'll be implementing later, which would have another method in the service for its usage. As of now, these are the three methods that we are settling with. But then we don't have any server right now, so we'd like to create a server first and then come back to our service.js. But I believe everyone is clear on these three methods. Like, why have I created three methods specifically? Yes, everyone? Very good. Very good. So this being done, we would like to go for the JSON server library, and it's a very simple syntax to run a JSON server. You don't even have to install it. You can just go with the npx JSON server, and the port number could be 3001, because by default it'll run on 3000 port, which is already used by React, so we don't want it to be conflicting. And then we just give a file name like db.json. All right, so this would actually create a db.json file for us, and this would have certain resources pre-built, and then we would be adding our task resource to it, and then we'll be checking the output on the browser. Let's see how that happens. So I'll just copy this command, and let me open up, like, the place that I want to create it is in this task manager folder itself. So I'll just command line it, and I'll just go with let's say JSON server or npx JSON server, port number 3001, and db.json. Hitting enter would just first it will say that there's no db.json available, but then it'll create a db.json for us, and it would have three resources: posts, comments, and profiles. So basically, if I copy this posts and I paste it in maybe my browser, you see that it gives me an array which has one post element. So this is the way this works now. Posts, it's a get request that we are firing in, and you can see that it also updates the log, and then it could be a post request as well on the same resource. And if you want to have a specific ID, you can have like post/1. I'll give you that specific object and all. So delete also is possible this way. So browser would only be capable of going for get request, but you can use postman like tool to get all the other types of requests fired. So these things are still possible in JSON server. It's a REST API server. So these are possibilities that the JSON server would have for us. All right, so we would just check out the db.json that it created for us. Let me just go to my task manager, and you can see that there is a db.json that is available. And again, doesn't have to be inside the task manager project itself, but because I want to commit this project to GitHub, I'm just putting this db.json inside the task manager project. It could be outside as well, and that's why I've run the npx json server command from inside the task manager project. So let's check out the db.json file. And there you go. There's a key value pair, and each key is a resource. And I would like to create my key, that is tasks, which would be having an ID. And it is a JSON file, so we'll not be able to go for that new task kind of a thing, because it is not a JavaScript file and it's just a JSON file. So it's just text that we're typing in. So ID, title, learn JSON, description. So all the rules of JSON creation would be followed in here, like double quotes are only allowed for a string. You cannot use single quotations. Keys has to have double quotations. Numbers are allowed as values, and booleans are allowed as values. Arrays are also allowed as values, so that is all possible. And the whole thing should be an object. That there are some rules of a JSON file. And completed. False to start with. Date. There's no new date kind of a possibility. So I'll just put in some date manually. Right, something like this. Add certain more tasks, like 3 or 4 tasks would be fine. I'll just make sure that the IDs are different, and later on JSON server would actually generate IDs for us automatically. All right, 4 can be. All right, so something like this. I've added my resource in this db.json file, and if I restart my server, you'd see that now we have one more resource displayed in here, which I can copy, and I can start firing requests at that resource. Like a get request from a browser to that resource would mean that it'll give me all the tasks. Maybe a get tasks/2 would give me that specific task only. You can have a delete request, you can have a post request, a patch request, any type of request, but the browser would not be capable of firing it out. So you may want to use something called Postman or some other tool like that to fire that kind of request to the JSON server that we have created. So pretty simple way to create an API server with REST enabled, but it is a dummy server. You would never use in a production environment. It is just for learning and testing purposes. But I believe everyone gets the whole idea of how a JSON server can be created. And later, yes, you have to replace it with your own backend, like a PHP backend or a Node.js backend maybe, or a .NET or maybe JSP backend. All right, so I believe everyone gets the idea of how to create a JSON server. Very good. Very good, guys. So now I'll keep this JSON server running on port number 3001, and my React application is already running on port number 3000, which is here. All right. So both these servers are running in. That is the requirement. And I'll close up this JSON file. And now I come to the task service, and we know that Axios has certain methods that gives us, all these get, post, put, delete, patch kind of a thing. So I would start with this get tasks. And what I also want is the API URL should be stored somewhere. So let me just go for the config folder. I think this is a good place where you can store the api.js file. And we'd like to maybe export const base URL. Base URL would be localhost 3001, and also task URL would be basically base URL plus / tasks, right? This kind of it. So then you can imagine that there'll be a user's URL and so on and so forth. Like there will be so many other URLs related to other resources. But as of now, we just need the tasks URL to be exported. So it's a good idea to put it in a different file and export it so that we can import it inside the task service. So I'll import it inside the task service. Import task URL from config API. All right. And now I would like to request, but then I would need Axios added as well. So I would add Axios here. You can go with yarn add Axios or npm install Axios, whichever the dependency manager that you're using. So let's wait for this to get added. Meanwhile, let me drink some water. And there you go. Axios is added. And what we would like to do is import Axios from Axios. Right. So here I can do something like axios.get and axios.get task URL. You can just pass the task URL directly. And once this happens, let's see if I can call this method somewhere. Well, here one of the components is a component that we would like to call the get tasks in, but which is basically the task list component. And apparently the task list needs the get task function. So eventually we'd like to call it here, but because we also want Redux to be involved as far as API calling is concerned and the service layer is concerned, I'd not be calling it inside the task list as such, but there'll be a Redux-Saga layer that will be calling the service after all. So as of now, what I'm trying to do is I'm just trying to test this whole service. So I would just go to the main file, that is index.js, just for the testing purposes. I'd import the service here and I'll just test this service. All right. So let me just open up the console as well so that we can check whether the service is working or not. But later after we test the service successfully, we'll just take this away. So let me just go for, let's say, import task service, or maybe we can use that import syntax like import star as task service from services task service, and then I can simply go for a task service dot get tasks as a method. So as I do that, I have probably logged this door somewhere. Let me just delete that. All right, and let me close everything up. So as I do a get tasks, I'll not see anything in here because I've not done any console log. But if I go to my network, I should see some Yep, you can see that there is a request that is going on inside your network to the 3001, and it's giving us a response as well. Now, if I want to show this response in the console, what I have to do is, let me just pull up the console. In the task service, because this axios.get is something that returns as a promise, if I want to handle a promise, can anyone recall and tell me what would be the function that I'll be using? Get task.url dot what? Dot then, right? Dot then. So if I say then and response, let's see what we get inside the response. So I do a console.log response, and if I save it, and the index calls in at the get tasks, and in here inside the task service.js line number 6, you get this whole bunch of things like the whole response object, actually the headers, the request headers, the status text, the data, everything from the response is what you get. All right. I would not like to go for the then in here to start with, but I would come back to this axios.get tasks. But what I'll try to do is I'll try to just return axios.get. All right. And when I do a return axios.get, this get tasks itself returns as a promise, which means every time a get tasks is called, you can actually do then in here, because get tasks itself, now it's a promise. I can just do then, and I can simply display the data. Or maybe let's say I want to show the tasks, or I want to show the response, and just do a console.log of response in here. So this is the ideal way that we'd be going for. We'd be returning the promise inside get tasks altogether, and we'd be calling the promises then method in here. So two different files. And now you can see that index.js line number 14, here I'm getting the console log response. All right. So here you have the data, and we know that we are just interested in the data, so I can go for a response.data in here. But we'd also like to go for another technique where we'd like to basically chain the then methods. So I do a then response, returns as response.data, or I'm doing a fat arrow function return, so I don't have to basically go for the return statement. So what this does is this axios.get task url.then gives you a response.data in return, which indeed is grabbed by this response. This now becomes tasks, actually. I'll name it differently. All right. And this just shows you the response.data. That is basically the tasks that are there. All right. So this is the chaining of then methods that we are achieving. All right. So here there is one then, and this whole thing is returned. And wherever you call the get tasks, there is another then method, which gets the exact response that we need. All right. So this response is a very big response object, but what we are interested in is just the data right now. So we're doing this two then methods, chaining them in two different files. All right. So I believe this whole chaining of then and the get tasks function call itself is clear to everyone, right? Axios returns promises. Yes. Axios.get put post delete, every function returns as promises. That's correct. All right. What about other participants? Very good. All right. So I would just like to make sure that everyone is clear on this. So if you have not replied, please reply. Okay, good. Very good. So the same way, like now I'll just take this off from the index.js. We don't want it over here. We don't even want it in the task list component to start with. We would like to have Redux-Saga involved, and we'll see how things go. And then I would also like to have other functions mentioned here as well. Like for example, add tasks would be returning axios.post, because it's the add task, right? Task URL. And when the URL is passed with a post method, you always pass a payload or a data that that this axios.post would have. All right. So this would basically post the data, and then I would do this return. So with Axios, this response.data return is pretty natural. Axios would return the whole response object. Most of the time, you'll just require data And that's basically what we'll be doing here for all the requests that we send. And similarly here it'll be Axios dot delete task URL plus slash the ID, and then again the usual. The delete, by the way, JSON server doesn't give you anything, it just gives you a blank object, but still we are following the same provision that we are following for all the other methods. So this is our service layer to start with. There'll be probably one more method going on inside the task service, and then there'll be other service like user service later on when we go for authentication kind of a mechanism. All right, so I believe this task service is pretty clear to everyone. Yes, please confirm. All right, very good. And you might have noted that in the task manager project itself, we have not created any promise, but we have just used the promise that Axios provides us. All right, but we would soon create a promise as well, but that'll be a different story. All right, so this being done, we would now like to just go to our diagram, that is the task manager.docx file, and we'll just try to make sure that we get where the service layer would be fitting in. We see that we have already given this kind of a service layer. So basically what would happen is that the model would be also containing the service layer, and later on you'd see that there is something called Redux-Saga that will come into the picture that would be interacting with the service layer. So this kind of a establishment is already something that we have done. Service basically interacts with your server. So server is any server. All right, so I'll just put it this way, just making sure that everyone gets that I want the service layer to interact with any server whatsoever. All right, so this is something that would happen, but the only thing is, like, what would be calling the service layer? It's a different story altogether. So now I would like to also do one thing where I would like this to be Redux. Okay. All right. And I'd like to just make some space and define my model layer or model inside my MVC even better. So it would be something like this. It is right now, it is the service layer and Redux working together to form my model layer. Right, so this is my model. Okay. So this is my model, which basically consists of the service and the Redux at this point. Then there will be Redux-Saga as well coming in. We'll see how things would go. As of now, services are not connected to anything. It just is interacting from the, or it's getting and putting the data to the server. Later, we'd establish a connection between the Redux setup and the service layer as well. Right. So this is the updated diagram that we have of our setup, of our architecture of the task manager project that we are doing. I believe this is clear to everyone, right? Very good. So let's close this up. And now we'll come back to ES6 just to learn one new syntax. And that syntax is something called generator functions. So as I said, we were preparing ourselves to apply Redux-Saga. Generator function is the last straw that we are drawing. So learning promises, the service layer implementation, and the generator function would give you a very good understanding on what is basically what is required to go for the Redux-Saga implementation. So here I'm still not talking about Redux-Saga at all. I'm just talking about how to create a generator function and what is a generator function as far as JavaScript ES6 syntaxes are concerned. All right. So let's just talk about that. So when we talk about a generator function, A generator function mainly would be something that would allow you to uh, generate a response or yield a response one after the other. And also, in a very abstract manner, these are the functions that are capable of pausing the execution of themselves and ending the JavaScript program altogether. So every, let's say for example, you have like 5-10 lines of code, 10 lines of code in a function, in a generator function, and you want to pause the function execution at the 5th line, you can do it, and then your program would also stop. That kind of a capability is what generator function has. You can resume the execution as well if you want to. So it's sort of like a sleep kind of a mechanism, sleep and wake up kind of a mechanism, as far as majority of other programming languages are concerned. All right, so this is the way that we create a generator function. Function star my generator function. By the way, it is different from the normal function. All right, so say for example, if I do a normal function, console log, let's say, all right, console log 1 through 8, and if I call this, it's a normal function, okay? And if I run this program, you can see that it executes right away. But if I declare this one as a generator function, and if I call this, all right, a generator function is declared by a star and asterisk right after the function keyword, and if I call this would not execute. First of all, it would end the program, but this function doesn't execute. This generator function always returns us a generator object. All right, and we can do a console log of the generator object, and let's see what we get here. If I run this, you can see that we get an object generator function. So, or an object generator, basically it's an object of the type generator essentially. So this happens, and then as I said, like, you can pause the execution in the midway if you want to. So this is like with the yield keyword, I can do a couple of yield syntaxes and I can actually pause the execution. So say for example, if I want to just go up till this yield, all right, I can do something like my generator object dot next. When the first next is called, this yield, up till this yield is executed, and it would not wait for anything. It will not keep the program running or anything like that. After this, the program would stop. So if I do this, you can see 1, 2, 3, which is this, and the program stops. So it doesn't actually keep the program running. That is also a beauty of it. So it doesn't mainly hold the thread, just releases the execution. So if I do a my object or my generator object dot next the second time, what we can expect is the second yield statement can be executed. So if I do this, you can see that first 3 and the second 3, and the program stops. If I do it for the third time, the rest of the part would also be executed. All right, so you can see that we are actually intermittently pausing the execution of the function, yielding certain results. Also, this yield is very important, by the way, which is only possible in a generator function. This is basically something that returns us data. Like, if we execute part of a function and at this point we want to return something, we do it with the yield syntax. It yields us some data. So in that case, let me just demonstrate one other thing, like const response 1, const response 2, and const response 3. So basically what we are trying to figure out is, what is this next giving us as a response? All right, so let's see what it is giving us. So if I do a console.log of response 1 and console.log of response 2 and console.log response 3. All right, so we are just taking a response, logging it. So let's see what the generator.next gives us as a response. You can see 1, 2, 3, and then there is a value that is undefined, but more importantly, done false, which is basically a flag whether the generator function is done or not. Similarly, on the second yield, it is done false. On the third next, it is done true. All right, which means that there's nothing more to execute. All right, and then there is a value that is undefined. This is basically the result of the yield function. So if I For example, let's say yield high and yield by, for example. So if this is the case, then the value will be the result of the yield function altogether. So in the midway, if you want to return something, you go with the yield keyword. But at the end, if you want to return something, you go with the return keyword right at the end of the function. So if I rerun this again, you get at the end the value test, and done would be true. All right. So this is the syntax of a generator function: intermittently pausing the execution of the flow plus yielding a certain result right in the middle if you want to. All right. And this is how basically it can be executed. So you would observe that in Redux-Saga, every function would be a generator function, and you'd not be returning anything, but you'd be yielding so many things. However, you'd not be doing my generator object.next. That'll be done internally in Redux-Saga altogether. But whenever you go for Redux-Saga, the syntax would be something like this: every function in Redux-Saga would be a generator function. All right. So I believe this that I have explained about the generator function and the syntax, I believe this is clear to all. Uh, Shweta asks, why empty bracket without the yield? Well, you mean like if I don't do yield high and just the yield kind of a situation? Is that what you're asking, Shweta? If you can restate it, please. I still don't get it. Without Sage, first output in the console. All right. And if I just go for this yield, let me just output in the console. All right. So this is the output. So you're talking about this value undefined kind of a scenario. You can unmute yourself, by the way, rather than typing it out, so that it will be even clearer. I cannot hear you though. Yeah, no problem. Go ahead and explain it once more, please. And meanwhile, I would just see what Rita is asking. If I don't want to break the output, then still do we need generator function? Well, no. If you don't want to basically break the output in intermittent intervals, you don't need generator functions. So that is basically not required at all. And Redux-Saga is actually something that would pause your executions of functions, and it will try and get the output in a way where it doesn't hinder with the current thread that is running in. And at that point, for Redux-Saga, we'd always need generator functions. That is the syntax of Redux-Saga. It always accepts generator functions only. The whole idea is not to keep the thread occupied and have the function sleep for a while the other processes run. That is basically the whole idea. All right, Rita? I believe that answers your question. And Shweta, without the usage of yield, anywhere in the console outputs blank bracket no. So if I don't use yield at all, it would just execute everything. All right. So, if even if I don't do a return test, and then if I do this, you can see that it executes everything. And then at the end, it gives you like these three. Like on the first next itself, it executes the whole function, then gives you the response, and you can see that done is true. So there's no blank bracket display or a blank object output anywhere at all if you're not using yield function, basically. All right. So this is some syntax on generator function, and this syntax would be used more. But just remember the fact that generator functions are used so that you do not hold, or you do not basically hold the execution of your thread and the other processes execute while your generator function sleeps. And only when the requirement of the generator function arrives, it does that wake up call, and then it executes again. So that's the whole idea behind Redux-Saga. And we'll see more about it during Redux-Saga, because Redux-Saga would be listening to all the actions, and we don't want Redux-Saga to hold the whole thread to keep on listening to the actions. So that's why they use this generator functions and all. So more on that later. We would like to go for Redux-Saga in the next session, but I believe in today's session we went through creating a service layer with Axios. We went for creating a dummy API server, which I would like you to replace it with your own backend server. And then we went for promise creation, and we also used the promises with the then and catch syntaxes. And also we learned something about asynchronous programming in JavaScript. It was more or less sort of a theoretical session, except for the fact that we had this service layer created, but now we are all set for implementation of Redux-Saga. So I believe everyone is clear on whatever we have implemented today, whatever the agenda that we have covered today. One final confirmation, everyone is clear with it? All right, very good, very good. So yeah, so let me just add this out in our GitHub repo. Meanwhile, if you have any questions, you can follow the repository, maybe fork the repository as I said, and you can get the code right away, cloning it from there. So if you have any questions right now, you can ask them out. Else, we can call it a day. You can say 0 so that we can call it a day. Today is day 6. All right. Okay, so let's call it a day then, and we'll see you day after tomorrow, that is Wednesday. And up till then, take care, bye bye, and God bless.